In the last video, we did a chi-squared test to compare the probability of improvement for real acupuncture, sham acupuncture, and non-acupuncture treatment. We ended up with a really small p-value, which means we have strong evidence to conclude that at least one of those treatments is different. So what we're going to do now is a follow-up to try to figure out which of those treatments are significantly different from each other. So there's a couple of approaches to do this. One of them is using residuals. So we usually think of residuals as just the difference between actual and predicted values. Here we're going to use a little bit of a different form of the residuals. So it is going to be the observed minus the expected. So that's a pretty clear connection to the residuals like in regression. But we are going to do a kind of standardization. So we're going to divide that by the square root of the expected count. So you can sort of think about how this connects to the chi-squared statistic. It's sort of like each term of the chi-squared statistic, the square root of that, right, with a positive or a negative sign. So let's calculate it for the first cell, just so we can sort of see where this number comes from. Okay, so this is the one for non-acupuncture treatment where the patient did improve. By the way, I just noticed that this says none. This doesn't mean that the patient wasn't getting any treatment, just that they weren't getting acupuncture. Okay, so for that cell, we're going to look at the observed count, which was 106, minus the expected count, which was 153.9. I'm rounding a little bit. And then divide by the square root of 153.9. And that's where this residual comes from. So that's where we get this negative 3.863. Okay, so we can think about how to interpret these. First of all, just interpreting the sign. If your residual is greater than 0, then that means that there were more in that cell than expected. More in that cell than expected. And if it's less than 0, then that means that it's less than expected in that cell. You can also, because of how it's standardized, you can think about the size. So these are going to have a roughly standard normal distribution. And so we say anything that's past, maybe 2 or 3 would be pretty unusual if there were really no association between these variables. So if we look at the size of these residuals, the biggest residuals that we see are for the non-acupuncture group. So let's look at the direction of those. So in the non-acupuncture group, patients were less likely to improve, right? We've got a negative residual for the better category. So they were less likely to improve than we would expect. And again, whenever we say expect or expected value, we're talking about what we would expect if there were really no association between the two variables, right? If really all of the treatments were equal to each other. So we sort of see non-acupuncture standing apart from the others. Another way that we can follow up is by using confidence intervals. So I have 3 confidence intervals here. And I'll talk through the code in a later video. But basically, this is the confidence interval for the difference in the long run proportions. So we can think about the true probability of improvement for the non-acupuncture treatment minus the true probability of improvement for the real acupuncture treatment. And that's what's being calculated in the first one. The second one is for pi real minus pi sham. And then the last one is for pi non minus pi sham. So here we are following up with some, we call these pairwise tests, right? Comparing just 2 treatments at a time. You wouldn't want to start with this because of the possibility of type 1 errors. But once you've already rejected the null, it's reasonable to follow up in this way. Okay, so think about how we would interpret those confidence intervals. If the confidence interval includes 0, basically what that's saying is that 0 is a reasonable value for the difference. So if we look at, let's see, real and sham, that one includes 0. So our interpretation would be that it's plausible in this case that there is no difference, right? 0 is a reasonable value. So it's plausible that there's no difference in the probability of improvement. That's what the pi stands for real and sham acupuncture. So what about when 0 is not included? That means that 0 is not a plausible value for the difference. So in this case, 0 is not a plausible value for pi non minus pi real or for pi non minus pi sham. So another way to say that is that non-acupuncture treatment is significantly different than the other two. Non-acupuncture treatment is significantly different than the other two treatments. Another benefit of confidence intervals is that besides saying that we have strong evidence that the two groups are actually different, we can actually estimate how large that difference is. So let's do this for comparing real acupuncture to non-acupuncture treatment. So we would say we are 95% confident, right, starting like a regular confidence interval, that real acupuncture increases the probability of improvement. So I'm putting this in context, the fact that this difference is negative for pi n minus pi r, increases the probability of improvement by this amount, so by 0.1356 to 0.2689, and that's compared to non-acupuncture treatment. So obviously this isn't the only comparison that we could make, so we want to make sure we're explicit about that. Okay, so this is telling us how much we expect the probability of improvement to increase. And I'm kind of running out of space, but I think it's pretty clear that we could do a similar interpretation to compare sham and non, just using that same format as before. Okay, so this follow-up gives us much more specific information about which treatments are different and how different they are.